Okay, so we're going to go back down here and tackle these last few categories. I was going in color order, but I won't make y'all read yellow, so I will go to orange. All right, so we are on class 6. Let me zoom in a little bit. Oh, goodness. Okay. We are on class 6, which is RNA viruses that reverse transcribe. And these viruses are also called retroviruses. And you're probably going to hear it both ways, reverse transcribers or retroviruses. So I will write that. Okay, so I'm going to go ahead and write out the whole plan, and then we'll talk about it. So we start with positive sense single-stranded RNA. And we go here first. We're using an enzyme called reverse transcriptase. And like it sounds, sorry, I can't write and talk at the same time. Reverse transcriptase. Like it sounds, it is what is going to reverse transcribe the genome. All right, and so it's going to reverse transcribe it into double-stranded DNA. This is also called cDNA. Because it is circular. And it is, like I said, aided by the enzyme reverse transcriptase. So reverse transcriptase can be an RNA-dependent DNA polymerase, a DNA-dependent DNA polymerase, or an RNase H, which can degrade portions of nucleic acids. And so it functions in a lot of different ways, and so that because these viruses have to be so small, they don't want to have to bring a bunch of things with them. And so it helps that this has multiple functions within this process. I'm going to go ahead and abbreviate just so we can cut down on time here. And RNase H, which, like I said, degrades proteins. Or sorry, not proteins, portions of nucleic acid. Okay, so now we go back here. And we take the next step here, which uses integrase. And the good thing about all of these enzymes is they all sound like exactly what they do. And so this is going to integrate the cDNA, or the double-stranded DNA, into the host genome. And so at that point, it's called proviral DNA. And I'll go ahead and write a note out here. Okay. So, like I said, this is now called proviral DNA. From here, we can go back to the previous model of replicating the genome and then also making proteins. So we're going to split here. Make this one pretty long. And at this stage, we undergo full-length transcription. Back into the positive sense single-stranded RNA that we started with. And that is the genome, and that is what is going to be packaged into the nucleocapsid. But we have to have something to package it with, of course, and so back up here, we are doing transcription. Into the mRNA. I guess I'll make this one longer. And then finally translation into proteins. And like before, these proteins will form the nucleocapsid that the positive sense single-stranded RNA genome will go into, and they will all assemble. All right. So some examples of this. Well, I guess I'll just give one example because it is really the main example that's used to describe this class, and it's human immunodeficiency virus. And I'm sure you have all heard of that. Because of course it is abbreviated HIV, which leads to AIDS. And so this is probably obviously the most prevalent example of the reverse transcribing RNA viruses. The other type, here I'll change colors here so we have a distinguishing. The other type of retroid virus is DNA viruses that reverse transcribe. And so that is class 7. And our final class, DNA viruses that reverse transcribe. And just so you know, the term retrovirus doesn't have to do with just the DNA or the RNA ones. It has to do with both. So whether it's got a DNA genome or an RNA genome, if it reverse transcribes, it is called a retrovirus. All right. There are 2 viral families that belong to this category. We have, I'm going to mispronounce this, I'm so sorry, Colymoviridae, which infects plants, and we have Hypnoviridae. Here, I'll put at plants. And Hypadnaviridae, which infects animals in the form of hepatitis B. All right. So hepatitis B is partially double-stranded and partially single-stranded. So I'm going to go ahead and draw that out over here. I guess I've run out of space going to the right. So we'll say it is partially DS and partially SS for single-stranded. So the longer strand is going to be the negative sense, and the shorter strand is the positive sense. Oh no, I've run out of space. Okay, I'm going to go ahead and continue down here. Hopefully that's okay with y'all. I'll leave it here, so if you want to pause the video, you can look at these, but I'm going to go ahead and draw out this whole type of thing down here a little bit. All right, so we start with the ssDNA / DS DNA genome. And this, don't get this confused with the ambisense viruses that we talked about before. Those are where there's it's single-stranded RNA, but it's positive sense and negative sense. Even though this is also sort of a mixed genome, that is not the same thing. All right, so the process of how this genome gets to the double-stranded DNA full genome is unknown. But this whole, right here, we have double-stranded DNA. When the whole genome is in the double-strand of DNA, it is called the CCC DNA. I'll go ahead and make notes out here. So the CCC DNA is called this because it's called the covalently closed circular DNA. And obviously, it is much easier to just say CCC DNA. All right, and I guess we can put the note here. This here is also called the relaxed, the RC DNA, or relaxed circular DNA.